video too or no?
It's making a video of a screen, video
Okay.
of with everything that's on the screen, and then the audio is just the ambient noise in the room, which when I'm by my computer will be mostly me. So you'll get me talking, and you'll get what everything on the screen. So it's full reproduction of class, and so that's called screen recording software. It's very readily available. So recommend that as really helpful for your students. Okay, so we were talking about the fact that you found that his speed was 10.4 meters per second, but then we said, well, no, he ran lots of speeds. He didn't run 10.4 meters. He ran lots of speeds. And it's true. If you went from 0 to some velocity in an instant, you would die, okay? Because that's infinite acceleration, right? That's infinite acceleration. If you have infinite acceleration, it requires infinite force to do that. So you would be crushed, okay? Even going from 0 to 1 mile per hour instantly would kill you, okay? You have to go through all those speeds. You have to accelerate up to whatever your cruising speed is, okay? That's just that. So he ran lots of different speeds, but when we did this, when we found his speed, we got this one speed, 10.4 meters per second. So what's going on here? So then what's the meaning of that 10.4 meters per second? Andrea said it's the average speed. Well, what's that? Are we adding up all the speeds and dividing by the number of speeds? Like a test average? Were you gonna chime in? Oh, okay. So what do you think? What's the meaning of this average speed? What does average speed mean? 10.4 meters per second. If you didn't run that speed the whole time, you ran a bunch of speeds, then what does the 10.4 meters per second have to do with his race?
Well, it does get us a feel for how fast he's going.
Okay.
So without that, we would just not be able to understand how fast he was going, or see if he was going faster.
Exactly. It has to do, right. It does give us a picture of how fast he ran, but how does it do that specifically? How does it give us a picture of how fast he ran? You want to?
Actually, so I know you guys found it per meters per second.
Yeah.
But I just went ahead and did it in miles per hour.
Okay.
Just because that's more understandable to what I know.
Okay.
But I did 23.88 miles per hour. So that gives me an idea of how fast.
Alien freak, right?
Because that's in a measurement we all understand. So if you just, and it also depends on the units, I guess.
Okay. All right, so he's running like almost 24 miles an hour. That's incredible, right? So that's
But he keeps that up for a whole hour.
No.
Exactly. No, it's a good point, right? So he can't exactly. He's not.
He's running that amount for 9.58 seconds.
Okay, he went that speed for 9.58 seconds. Were you gonna say something?
I was gonna say, so like the 10.4 is basically like we said, he's like going all these different speeds. Like he's probably like slow at first and speeds up and slows down as he gets
right.
to the end.
Okay.
So we're pretty much taking all those different speeds that he has and like putting it at an average because it's like sort of if you said, oh, he went this.
So
this time.
kind of sounds like you're talking about a test average, kind of like add up all your scores and divide by the number of scores.
Yeah, it's sort of like that, but it's hard to explain.
But yeah, that doesn't really work because how many different speeds did he run in the race? An infinite number, right? If he's going from 0 up to 23 miles per hour, he's covering all those speeds in between. So it's not. So again, yes, this 10.4 meters per second gives us a feel for how fast he's running, but how specifically does it do that, Andrew?
If I remember right, it is the average between the starting speed and the ending speed when he crosses the 100-meter line.
So average.
So you would take 0 as one of
Okay.
your, as the initial speed,
So,
and then whatever speed he had when he crossed the 100-meter line, and then divide by 2.
okay, what do you think? Tell me your name.
Sophia.
What do you think, Sophia?
I agree with like that top part, but when you divide by the change in distance instead, because
Okay.
what you're saying would still be kind of maybe.
Okay, so we're still talking about like an average, like finding an average of values, right? A finite number of values.
I think with adding in the end speed could be flawed because in watching his videos, he slows down at the end too.
A little bit at the very end. You're right. These
So
when they
his
get to like the
max
very
point
end, they
is like in the middle.
yeah. Okay, so any other ideas? What does the 10.4 meters per second mean? How does it give us a feel for his race? Okay, well, I have something to maybe help us out with that. I have a new runner. It's Emma. Go, Emma. You can be the world's fastest person. You can do it. Come on. You can do it. Oh, it's a tie. All right. Maybe she'll do it this time. She's really fast. Oops. Okay, try again, Emma. Come on. You can do it. Okay, so this is to help us understand how 10.4 meters per second is telling us his speed. I've added her as a new runner to help us understand the 10.4 meters per second for her. So hold your thoughts for a second. We got a worksheet here. So let's just do 1 through 4. 1 through 4. You can talk as you're writing. Okay, so actually, I want you to talk. It's not that you can talk. Discuss your answers as you're going. Discuss your answers as you're going. Just do 1 through 4. Just do 1 through 4 on the front page. Okay. Did we finish 1 through 4? So a couple of people raise their hand before I hand these out. Are you? Yes. Tell me your name. Kylie. Yeah. So we're trying to make sense of the number 10.4 meters per second as it pertains to Usain speed, right? So what were your comments?
So 10.44 is the
what she said. So how is it helping us? So talk about the animation. So what's happening in the animation?
So Emma is the one traveling at the constant speed.
Okay.
Sane is like accelerating as he goes throughout the race.
Right. Okay. So how does that help us understand this calculation we initially did of 10.4 meters per second? Tell me your name again. Yeah. Shelby. So does having Emma in the picture help us make sense of that number, that 10.4 meters per second? Did it help you?
Yeah. Well, yeah. Because we can see that she can travel at that constant rate,
Uh-huh.
but that even though he has the same average, he's not traveling at a constant
Okay.
rate. But they completed at the same time.
Same distance in the same amount of time, right? Yeah, more comments.
That's one of his top speeds.
It's one of his, is it his top speed?
No, but it's close to it.
So somewhere in the race he had to have run that speed, for at least for a moment, yeah. Because he's running slower at the beginning and then faster at the end. So somewhere in there he's going the same speed as her, that's true, yep.
Well, he has to run a lot faster than her for enough time to catch up with her, and then the minimum he can run after that is 10.4 meters per second.
Okay.
He has to speed up and have a higher average than her for a good amount of time.
Okay.
And then when he reaches her, he can have the same speed.
Okay.
But he's going a lot faster than 10.4.
So in the middle of the race he is going faster than 10.4, that's for sure, yeah.
Yeah, so say it's like he has to reach a maximum that he can to reach up to that 10.4 that was already being established, kind of a thing.
Okay.
Does that make sense?
Okay. All right, so back to when we say that he ran 10.4 meters per second. What is that number? That 10.4 meters per second is only one speed, right? So it's a constant speed. It's like Emma's speed, right? So what constant speed is it that helps us understand Usain's race? What constant speed is it? The constant speed that? Is it just any constant speed that you could run? Right, and that which is what Samuel, that's her brother, Usain did, right? So Usain, he ran 100 meters in 9.58 seconds. So this 10.4, it's exactly what Kylie said. It's the constant speed that he would have needed to run to cover the same distance in the same time. Because when you do this 100 divided by 9.58, you get just one value, so that has to be a constant speed. There's not more than one speed. It has to be a constant speed. So what constant speed is it? It's the constant speed that he would have had to run to achieve the same distance in the same time. Just like Emma, right? Just like Emma. The way Emma's right here. Okay, does that make sense? Yeah.
So would it be technically that that's not exactly how fast he ran, but how fast he completed the race? Because his actual speed could have been a higher.
So, is it how fast he ran? Okay, only at one moment. So, or at least, so there is a time that he ran that fast. But what this number means is it's an equivalent constant speed. It's a constant speed that would achieve the same result start to finish that he did. Right? Same distance in the same amount of time. So that's what that is. Even though he ran lots of different speeds, the 10.4 is like, it's what we mean by average is that it's the constant speed to get the same distance that he ran in the same amount of time that he ran it. Okay. Does that make sense? Have you heard that before? So, Kylie, it sounds like you've heard that before. You've kind of learned that before. That's good. Anyone else learned something like that before? That's a big pathways theme, right? So if you've been through pathways, then that should be very familiar. Okay, that's pathways. Okay, so those questions are to talk about average speed. What is an average speed? An average speed is a constant speed to achieve the same distance in the same amount of time. Okay, well then, part two. What's a constant speed? What does that mean? Okay, so let's talk about that. So I want you to answer questions 1 through 3. Let's just do 1 through 3. So if an average speed is a constant speed, then we better know what a constant speed is. Okay, so answer and talk as you go.
You were gonna get.
Are you done, or are you refusing to talk? So anyone want to offer up what you wrote your answer to number one? What did you say for number one?
Me? Sienna?
Sienna.
So I just said that you're always going to be traveling at that speed for however much.
And what does that mean? What is 70 miles per hour? What does that mean?
Well, you're going to travel 70 miles
In about an hour?
in 1 hour.
So it means that you travel 70 miles every hour. Did other people write something like that?
Yeah, we were saying like without external.
Yeah. So if,
Like
if
traffic.
you truly held that speed, then every hour you cover 70 miles. Okay. So then, my contention is it means something a lot more broad than that, and that's what question 2 was for. How do you know how far you go in 2 hours? So you know. So then how far would you go in 5 hours? Half an hour, 35, and 1/10 of an hour. So do you see? And I could keep asking those questions all day long. So you really know a lot more than just you go 70 miles every hour. Right? Because then I could ask you about 2.5 hours. I could ask you about a minute. I could ask you about 45 minutes. I could ask you about 12 hours. And you can answer all those questions. How many miles you went in 70 miles per hour. So can we come up with a much broader definition of 70 miles per hour than you would go 70 miles in an hour? Come up with a broader definition based on the fact that you know a whole lot more than that.
Would that be like the change in miles based on the number of hours?
Okay. So either change in miles would be what? Would always be what?
Would be 70 times how many hours?
Right. So what you know a lot more than just 70 miles per hour. You know that given any change in time, right? How far would you go? 70 times that change in time, right? Given any change in time, 70 miles per hour tells us your distance traveled is going to be 70 times that change in time. So this is the way we want to think about constant rate of change. Constant rate of change. It's more than just how much you get for 1 unit, right? You can know how much you get for any number of units, right? In this case, hours. Given the change in hours, multiply by 70, and that will give you the change in distance. Do you see what I mean? How that's like a much more general, broader definition of that constant rate of change? Does that make sense? Okay, so I want you to apply that to gas costs $2.10 a gallon. That's actually, I wrote this a couple years ago. That's right on the money right now. Okay, so if gas costs $2.10 a gallon, that's a constant rate of change. How would you describe the meaning of that $2.10 a gallon in a broad way, right? Not in a narrow way, but in a broad scope. How would you explain that constant rate of change? the hint. Very, very, very few people go to a gas station and buy 1 gallon of gas, right? Right? And does everyone buy the same amount of gas? No, right? So what does $2.10 per gallon mean? Somebody new. Jesus, you want to give it a shot?
I said given any change in the number of gallons,
Uh-huh.
the price will be $2 or 2.1 times that change in gallons.
You already said? Well said. You said given any change in the number of gallons that you put in your tank, what you're going to have to pay is 2.1 times that change in gallons. Okay, so part 1 we talked about a meaning for average speed, or average rate of change. What do we mean by that? So what do we mean by average rate of change? Leo? In part 1, our whole point in part 1 was to understand what an average speed was, or an average rate of change. And what did we remember? What we came up with? Okay, so there you're talking about the meaning of the constant rate of change. So that was more like part 2. What did we say was the meaning for average rate of change? Right, so it'd be the constant rate or the constant speed required to see the same change in distance for the same change in time. And then part 2, we said, okay, well then what's a constant rate of change? If that's an average rate of change, we need to know what a constant rate of change is. And so constant rate of change was then what Leo said, given any change in seconds. So who does that apply to? Does that apply to we say given any change in seconds, the change in meters would be 10.4 times the change in seconds. Does that apply to Usain? No, because he's not running at a constant speed. But it does apply to Emma, right? Given any change in seconds during the race, Emma will cover what? 10.4 times that change in seconds in meters, right? Okay. Any questions? All right, so there's a project that you will do later, like in October, that's actually kind of similar to this. Hopefully this one will open. And it's marble drop. Good. Okay, and so you are gonna, once you start becoming experts, you're gonna create this. And so this is another GC file here. And if you read the kind of the explanations over here on the right, it says the fictitious marble gets a running start and falls at a constant speed. The real marble falls by gravity, that's the blue one, and starts the moment that the fictitious marble passes it. So it's kind of a game. Give the fictitious marble a speed, that's FM speed, so choose the speed here. So let me just, I'll say 475, okay. So choose a speed for the fictitious marble so that they tie. So if I set go here, that was a little fast, right? So what happens? So as soon as the fictitious marble, the red one, passed the height of the real marble, they start to fall together. And then our goal is to set the speed of the fictitious marble, there it is again, set the speed of the fictitious marble so that they hit at the same time. So this said that it took the fictitious marble 2.105 seconds to hit, and the real marble took 7.885 seconds to hit, and this is from 1,000 feet. 1,000 feet up. Okay? So, do it. So what speed should I put for the fictitious marble so that they both land at the same time? And this is highly related to what we've talked about so far in class. So what speed should I set for everything's in feet and seconds here. What speed should I set for the fictitious marble so that they both land at the same time? Go. So let me just put something a little bit slower so it. I put 300. So this might be a little more. So this is 300 now. Still way too fast. Did you get it? Ready? Watch it. Here we go. So this is 300 now. Way too fast. We want it to hit now. Right? Tell me your name again. Jessica, did you get it? Not yet. Okay. Yeah. Well, so how did you get that? You got that too? Okay, a couple of people got an answer up here. What'd you guys get? 126.8. Is there one more decimal place? 82. We'll try 82. So they're saying 126.82. Did you guys get that? What is the 126.82? What is that? So it's the speed so that the marble will go the same distance in the same amount of time. So then if it's that, well, then what is it? What is the 126.82 relative to the real marble? What is it? It's the real marble's average speed, right? It's the real marble's average speed if it's the constant speed to go the same distance in the same time. Let's see. Nailed it. Good job. It kind of looks like it's not going to make it, right? But an object falling, it accelerates, right? It gets faster. Nice. Okay, so that's another kind of way of talking about the same idea of average speed is a constant speed, and this makes for like a game, right? Kind of a game you could play with your students. But the game that you're going to play is you're going to design that, and that's no small task. But by the time we get there, you'll have the tools to do it. Okay, was there a question up here? Okay, are you guys good? Yeah, it gets a little head start. So it doesn't really matter how much the head start is because this one doesn't start falling until it passes. Yeah. So the real marble starts at the exact moment the fictitious marble passes it. Yeah. So you can watch how the blue one stays still until the red passes it. Now they go together. So it's kind of like how you saw Emma come off the screen, right? She came from the left. She had a running start. Okay, other questions on that? Okay, so let's just open up. If you flip over your page there. So when you open a new GC file window, it looks like this. So we're going to get into a lot of the basic things that it does, but I just want to show you a little bit something here today from this example here. So in part 2, it says, suppose you open your laptop during class to take notes. 35 minutes after class started, your laptop battery is at 41% charged. 75 minutes after class started, the battery has a 28% charge. Okay, so I want you to find, can you find the constant rate of change of battery percent with respect to time in minutes? Go ahead and do number 1. And 2. So let's do 1 and 2. Do 1 and 2. what did we get for the constant rate of change? Let's check. What did we get? Rachel, did you get a number for constant rate of change? Tell me. 3.076? 3.08% per minute? Someone else get that? 3.08? No? What'd you get? 0.3% per minute? Okay, and is it negative or positive? Negative. Okay, so negative 0.308, so she's just off by 10? Or is this, was it negative 325? So something went wrong there. So negative 0.325% per minute. Okay, what's the meaning of that number? So you almost had it, but then you said it was the rate. So for every change in minutes, what?
Your battery's decreasing at negative 0.325 times
On a mountain, right? So yeah, so what you're about to announce is not a rate, but you're about to announce how much the battery power goes down, right? Yeah. Okay. So yeah, for every change in minutes, your battery will decrease by negative 0.325 times that number of minutes, and that's what we talked about earlier. Okay, so I want to graph these 2 points. So what is our, in this case, now that you found that constant rate of change, what is our independent variable and what's our dependent variable, or what are we going to use for x and y? Okay, she wants independent to be time and dependent to be percentage. Would you agree with that? That makes x what? X is going to be our number of minutes, right? And y is going to be our battery percentage. Okay, so to plot a point, you bring up this vertical vector, which is control 2. You don't have to remember that now, but I hit control 2, and I got this chance to make a vertical point. And so what's the first point going to be? Well, what is it? 0 and 100? Do we know how much it is at 0? No, we don't know. We only have 2 points, right? What's one of our points? 35 and 41. Okay? And then the next one is 75 minutes? 28. Okay? And so you can change the color of your points and then hit graph. Oh, didn't graph them. Why not? Window's wrong, so just like a handheld, you can zoom out, but a lot easier. And then you get these 2 points, okay? So what I want to do is I want to model the change in time from the first time we looked at the battery to the last time we looked at the battery, okay? And so to model that change in time, or to represent it, oh boy. So to model that change in time, I want GC to draw a horizontal line. That's supposed to be horizontal. Okay, straight horizontal line, like that. So what mathematical statement, so everyone think for yourself, what mathematical statement would reproduce what I drew there to represent the change in time from 35 minutes to 75 minutes? Is the question clear? So what mathematical statement, for instance, z equals the square root of y squared minus 80. That's a mathematical statement. What mathematical statement? So everyone think about it. I want everyone to think about it and work on it. Are you asking a question or are you answering a question? Okay, so then just write it down and discuss at your table. Everyone think about this. What mathematical statement would mean or represent this line segment that's representing this change in time from 35 to 75 minutes? Think about it, talk about it, see what you can come up with. While I make a better line. Let's start over. There we go. I want a mathematical statement that is equivalent to that. Equivalent to that black segment. What mathematical statement is equivalent to that black segment? So the first thing we need to ask is, maybe, what is it? What's on a line? All right, if you think you, let me see what you got. So, will that show that? I put y equals 41 in there. So that's going to show that right there. Okay. So how do you take that English? That English is exactly right. How do you make that mathematical? Okay. So what you said in English is perfect. A mathematical statement. Okay, so the first question, so some of you made some progress on this. The first question is, when you're looking at that black segment, what is that? What is it? The horizontal line. And so, but really, what is it in its essence? No, this isn't really a change graph. Okay, so we're using that line to represent the change in minutes, but the line itself, when you see a line on a graph, what is it you're looking at? Or a curve for that matter? What is it? Doesn't have to be a function. Collection of points. Number 5. It just would take too long to draw it that way, right? We don't want to go. It would take too long, and and then there'd be so many that it would end up looking like this anyway. But when you see a line or a curve and a graph, you should be thinking, oh, that's a mess of points. That's a mess of points. And so understanding that can help you answer this question of what mathematical statement then is going to give me all of those points. So all those points have what in common? Y equals 41. So if I stop right there, will that give me that segment? No. That'll be too many points, right? That will be every point that has Y equals 41. So which ones do we want? between 35 and 75. And what mathematical statement tells us that? What mathematical statement? I'm not going to write between, right? So? Okay, so we go, what, 35? You want to do less than or equal to? Okay. Less than or equal to x. So that's a mathematical statement that gives me the points that I want. You see? It's going to give me the points. So some of you had that. So here's the takeaway. GC is not a computer programming language. It's simply a device that you give it the mathematics and it displays it. Okay? You give it the mathematics. We told GC to graph all these points, and it did. It graphed all those points starting at 35, ending at 75, where y equals 41. Now, how did we use that? We use that segment to say, oh, this is representing the change in time. But GC doesn't know anything about that. Doesn't know anything about how we're using it. We're using it to show, oh, this much time went by, starting at time 35. Okay, so you got your 3 tasks for Tuesday, which are on Blackboard. Nice to meet you. Have a great weekend.